Welcome back to another video. Let's take a look at how we can obtain ASCII files. So for the case study I will go on Artec 3D scan over here, and we see a wide variety of elements that have been 3D scanned over here. I will choose this manifold. We can directly visualize the model over here. This has been embedded onto Sketchfab, so you can see it over here. But let's take a look over here within the free download section. We see the information regarding the scanning of this. And we're going to have the available download file formats: OBJ, STL, PLY, and WRL. For the case study, I will go with the STL file. I will save this on my desktop. I will go over here and I will have this extracted. Then we're going to see this will be the STL file. Now, in order to convert that file to an ASCII file, initially we need to open the model within the Digital Shape Editor workbench. I will select this to be on STL, so the file format, and we're going to see the 3D scan over here. I'm going to click apply and the model will be loaded. Now we can analyze the 3D scan, and we're going to see that this has quite a lot of details. So we see also the details for the logo and the number associated with this, so within the production. Now if I will go over here on information, we're going to see that the total number of triangles in this case will be 4 million. Now in order to save this as an ASCII file, we can use the export over here. So I click on export, the selection will be the mesh, and over here for the file format we're going to see a wide variety of formats. So initially the first one will be ASCII free, ASCII RGB. This will also have color. In our case the 3D scan didn't have color directly within the point cloud. We can also define a user format ASCII file, and we're also going to have STL, the one that we just imported, and SIGO over here. So I will go for the first one. I will call this BMW. I will hit save. And afterwards, for the axis system, I will leave this to be absolute. And regarding the grouping, I will go with grouped for the point cloud. If I will go with distinct, if we would have multiple elements, those will be added separately as separate point clouds. And now we have that conversion done. So over here we're going to see directly on the desktop that we have the BMW ASCII file, which I can open directly with Notepad. And we're going to have the information over here added as well. So this has been generated using Generative Shape Editor within CATIA. We're going to see the file format, so the coordinates for X, Y, and Z. This will be for each point. And the total number of points over here. If I were to import that, I can go now on import. I will swap this to be ASCII, and I can select that file, which will be this one. I can hit apply, and we're going to have the model loaded. So in this case, it should perfectly overlap our existing mesh. As we can see, that happens over here. If I will hide the initial STL file, so this was the initial STL file, I can hide it and I can visualize this. Now by default the sampling will be set to 100%, so in this case we see that the shape is not that easily visualized. Within the following video we're going to take a look at filtering, but we can also do a local visualize filter. If I will go to properties, over here I will go all the way to display mode, and we're going to have the sampling. If for example I will go to something like 10, we're going to see that this will be the output. So the points have been filtered, but just within the viewport, they are still present within the model. If I will check over here the total number of points, we're going to see that this hasn't been changed. So within the following video I will discuss filtering, and we're gonna see how that can change the number of points within point clouds. But we see how well those two have been overlapped. The main difference between point clouds and meshes is that point clouds will only add the coordinates for each individual point over here. Currently they are only set to have them displayed 10 out of 100, so the sampling. The mesh is way more denser than this. And if I will go back to 100%, we're gonna see how many points will be added. And afterwards the STL will actually merge 3 points to create a triangle, and that will give this the final mesh, in this case defined by triangles. We also have meshes defined by quads, but those are usually created within other software solutions, and we can also have them converted from triangles to quads. Okay, so I hope you enjoy this kind of content. I will position a similar video over here on the left side, and I will also add a subscribe button to the right. So see you within the next video when we are going to discuss the filter option. So that's it. Thanks for watching.